Welcome to the Wiener Hour, everyone. I'm your host, Stephanie Wiener, and today we have some scientists to answer all your black hole questions. Welcome to the show, guys.
Glad to be here.
Let's start with you, Gloria.
That's Dr. Hope, actually.
Ooh, we got a scientist here, all right. What can you tell us about black holes?
Well, as it happens, I can actually tell you quite a bit about black holes. The particular black hole that we're studying, Sagittarius A star, actually is not observable in the optical spectrum. This is for two reasons. The first one is because the very nature of a black hole is that it's a star, but it's a collapsed core of a star that doesn't allow electromagnetic radiation to escape from it in any way, so you can't detect it. But even then, even if you could detect it, there's 25 magnitudes of extinction between the black hole and Earth. And what a magnitude of extinction is that it's a measure of basically how electromagnetic waves are scattered and blocked by gas and dust. So this thing's really far away. Basically, the way that we can detect it is through, we use this thing called very long baseline interferometry, and it images the black hole in the radio spectrum, and that way we can figure out its mass. And its mass is about 4.31 times 10 to the 6. Solar mass is about 4 million times as massive as the sun. And Sagittarius A is going to be in its current state until Hawking radiation causes the black hole to radiate away all its mass. And we'll talk a little more about that later. But this process is logarithmic, and it will take about 10 to the 67th years, so it could even outlast the age of the universe. Some other interesting info I have is that a Sagittarius A star is classified as a supermassive black hole, which ranges in mass from about hundreds of thousands of solar masses to billions, and that there's a supermassive black hole like Sagittarius A star at the middle of every known galaxy. And a supermassive black hole can be explored a lot more easily than other kinds of black holes because of tidal forces. The smaller the black hole is, the closer you have to get to it to see it really well. And then the tidal forces refer to gravity's attraction between your head and your feet. So if your head's being pulled like 1,000 less times than your feet, you're gonna have a problem, as in like your entire body's gonna get ripped in half. So that's pretty fun. We have a satellite called the Swift satellite monitoring the Sagittarius A daily on X-rays, and we are actually currently in orbit around it.
Wow, that was really insightful. Now over to you, Jacob.
That's Dr. Stutz to you.
What can you tell us about black holes?
Okay, so I'm going to tell you a little bit more about the stages of the black hole that we studied. Its earlier stages, its later stages, and the current stage that it's in. It's currently a supermassive black hole, and it can be inferred that before that, Sagittarius A star was a really, really big star that eventually collapsed because of its huge gravity, causing this really violent, massive explosion that's called a supernova. And sometimes the gravity that caused that supernova is so big that the neutrons that are produced after that explosion can't stop the collapse of the star, and it continues to be squeezed tighter and tighter and tighter until the gravity starts trapping all of the light that's around it, at which point it becomes a black hole. And over the next 10 to 67th years, as Gloria said, Dr. Hope, the radiation from the black hole will start leaking, and it will eventually make the black hole disappear. But obviously that's a very, very long time from now, so yeah.
Thank you, Dr. Stutz. Now over to you, Dr. Wainwright.
You can call me Logie.
Excuse me, Logie. To wrap up this conversation, what can you tell us about black holes?
Okay guys, I'm going to be hitting with some of the basics like spectral class, temperature, location, and color. The temperature of the gas around Sagittarius A shocked observers because it was over 1,000 degrees Celsius in some places, which is much hotter than most interstellar material, which on average is negative 200 degrees Celsius. Sagittarius A is located at the center of the Milky Way, near the border of the constellations Sagittarius and Scorpius. The center of Sagittarius A is black, but the accretion disk around it has a bluish-orange color, and there is no spectral class for Sagittarius A because it's a black hole.
Well, folks, you heard it here first on the Wiener Hour. We're glad to have a chat with these black hole experts. I'll see you next week when we discuss the difference between ravioli and lasagna. Now we have some questions for you. Sagittarius A located? What most likely was Sagittarius A before it became a black hole? And how did Sagittarius A become a black hole? Thank you for watching!